So I'm Luis from the Aragon project, and I will get into what it is in a second. And I want to talk about how to create truly decentralized browser applications. And what this means is applications that are impossible to censor, even if you are like in China, behind a huge firewall, even if you are in Venezuela, whatever you are. And they are decentralized, and they can be community run. So we can imagine a lot of possibilities, like a decentralized Facebook, like a decentralized search engine like Google, a decentralized Dropbox, a lot of these things that care about user privacy, and they are impossible to censor and global, and run by the community and not by a central company which has their own set of interests. So first of all, what's Aragon? So Aragon is a project to empower freedom by creating tools that enable decentralized governance. And so now you will ask, what is decentralized governance? And before getting into that, I want to know how many of you have heard about the word blockchain. OK, and how many of you, when you think about blockchain, think about like scams and like crappy ICOs? I kind of think that way too sometimes. So there's a lot of that, but what I'm going to talk about today is the actual technology that is being built and that enables a lot of functionality. Everything that you're going to see here in these slides, you don't need any token at all to use. It's all free and open source, and it's actual technology that is being built grassroots and not by some kind of scam. So technology like this that we are seeing here, so this is the Aragon client, and this enables to do permissionless voting. So, for example, I'm from Spain, and I saw everything that happened in Catalonia when people basically wanted to vote whether to secede from Spain or not. And I will not get into a discussion of whether that's legal, illegal, whatever, but people were hit. People were detained. People were put into jail because they wanted to vote, and they were not allowed to vote. Because the systems we have today, they are very centralized, and they require you to physically go somewhere and vote. And that shouldn't be the case. If we can have purely decentralized applications like voting, that we can mathematically prove that you have voted some auction and some option that you can like prove on a blockchain, so everywhere in the world you can vote without going somewhere and getting hit by the police, that's a huge step forward. Not only for places in the first world like Spain, but also places like Venezuela or China, where there is a lot of censorship going on. And apart from that, there is also the component of efficiency. This is very efficient. You just go here, and for example, you want to make a transfer of money, and then you can just open a voting from here, and then vote in this beautiful application, which is a couple clicks. So I want to go into what we are seeing here. So what we are seeing here is a decentralized organization. And a decentralized organization is an organization, which can be a company, a nonprofit. It can be any kind of entity that in the legal world we will consider a company, a nonprofit, whatever. In the crypto world, this is just an organization. It's code. It's smart contracts. It's code running on a blockchain that you can customize. And then we have this beautiful front end that makes it easy for you to interact with these organizations. So an example could be, instead of going into like a company registry and creating your own company there and having to go through like a central government and having to pay a lot of taxes and registration fees and bureaucracy, which sometimes they even censor you. Like, I was trying to create my first company when I was 15, and the Spanish government basically was like, hey, you are not 16, you cannot create a company, wait till the Earth, goes another round around the sun, and then you will be able to create a company. And then I was like, OK, I just want to create some open source and get paid. That's it. I'm not like a terrorist or something. I just want to create a company. And with these tools, we enabled that. We enabled that anyone in the world, regardless of the gender, race, religion, whatever, they can organize, they can create companies, NGOs, whatever kind of organization that is global from day one, because it's living on a blockchain that runs across thousands of computers. And you don't need to rely on these centralized parties like governments or even central companies, which have very perverse incentives sometimes, as we have seen with all the banking crisis. And well, that was the whole reason that Bitcoin was created in the first place. and the crypto movement started. So I want to talk first about what is Ethereum. So how many of you are familiar with smart contracts and Ethereum? OK, well, that was more people than I expected. But anyway, I will go into it very quick. So basically, smart contracts are code that is run across all Ethereum nodes. And Ethereum is a blockchain, just like Bitcoin is a blockchain too. But it's very different, because in Bitcoin, you just have a lot of computers that are agreeing on whether you can spend some money or not. So basically, it solves the problem of double spending. So you cannot spend the same Bitcoin twice, which before Bitcoin it was not possible. In a decentralized manner, you had to rely on a bank to check if your balance was greater than 0 or not, and then lets you transact. Ethereum takes that philosophy to the next level and basically says, I want to be able to have any state transition. So I want to be able to have a network of computers that are running a virtual machine. And then you can execute any code there. And if the code is correct and you are creating a good state transition, then the state is updated on what is called the smart contract. And so here we can see a counter. So this is a very simple contract. This counter here just has a state, which is an integer. And then you can increment or decrement it. Very simple. And this happens on-chain. So basically, if you want to increment it, you have to create an Ethereum transaction and broadcast it to the Ethereum network. And then the Ethereum nodes will check, OK, is this address, is this entity allowed to perform this action? Can it increment the counter or not? And if it can, it will increment the counter. And if not, it will decrement. Like, very simple. And every single Ethereum node, every single node on the network can then fetch the new value for this counter. And as we see here, Ethereum is actually very reactive in the sense that if you see the events, the event keyword there, what we are saying is when someone increments or decrements the counter, we are going to emit an event. Because the Ethereum virtual machine is a virtual machine that is executing across thousands of nodes. And this consensus is great because you solve the problem of double spending. You can have a single truth of what is the state of any given decentralized app. But on the other hand, it is very expensive to execute. You cannot execute very complex logic here because it's going to be executed across thousands of nodes. And they require a fee for that, because otherwise they wouldn't be incentivized to perform any computation power. So you got to be very careful about what happens here. And so instead of having all the state here, as we will see later, we just have events. And then the clients can consume the events and can recreate, can reduce the events, and can create a final state that we show to the user. And that in the right is like the opcodes, like basically the stuff that it's like under the hood in this smart contract in the left. It's a fully featured virtual machine. So I showed the app before. It is a very simple, straightforward app to use. But it's a purely decentralized one, and it's purely censorship resistant. So I want to go into the architecture. So you see here the beautiful app, and then to the left you see some items, token manager, voting, and then to the right you see this voting app. But then if you go to the finance app, as we see before, it's a different app that enables you to do another different thing. And how we see this is, decentralized organizations and organizations in general enable you to create ways of human organization that were not possible before. So it's not just like a template like company or NGO, which is very rigid, and you have to choose one. Here you can like plug and play different smart contracts, different pieces of code to create your organization. So what we thought is we don't know how these organizations will behave because we just cannot predict the future. So we will just make Aragon into an app platform so people can create apps. And they can create apps like token manager, voting, finance, but they can also create very complex apps that do very different things. And so I want to get into how the architecture works, because what we are achieving here is we are kind of creating an operating system with all the security assumptions and sandboxing assumptions that has inside a browser. And so basically here you have the Aragon client to the left, and then you have a sandbox app. And so this sandbox app cannot do any malicious thing to the client. For example, when you deal with crypto and you deal with Ethereum and you deal with like money that is not held by a bank, if the user signs a transaction that they didn't want to sign, then their money is gone. So there are a lot of ways to deceive users into doing that, which is kind of the way like a lot of crypto scams are famous, because you can really steal a lot of money this way. And so what we do is these apps are all iframes, and then these iframes have some web workers, because as I was telling before, it is you have to fetch a lot of data from the blockchain. So for example, if you have a voting app, you have a smart contract similar to the counter. I use Zone. And what you have here is you have a lot of events. So when you do a vote, for example, to the smart contract will emit an event, which is there was a new vote. And then since this is purely decentralized, this doesn't have any single server at all. No Amazon, no Google Cloud, no server at all. This is purely decentralized, and it's peer-to-peer. What we need to do then is we cannot rely on a centralized server with a centralized MongoDB instance. We don't have that. So what we have to do is we have to watch the smart contracts. We have to watch the Ethereum blockchain and the state changes that happen there. And we have to slowly consume that state and reduce that state to something that the client UI can show. And so instead of doing that in the main thread, what we do is that each app loads its own web worker. And I will get into that later. And then you have the smart contracts. So each app has its own smart contract, basically, which the script, the web worker, is fetching data from. So this is how it would look like. So you see there it says server, but that's not like a cloud server. That refers to like the Aragon client, which is what apps are run inside of it. So you see like the Ethereum virtual machine down there, all the smart contracts, and then you see like the JavaScript part of it, which is basically the stuff that reduces the state, and then you have the client UI, which is the sidebar that we saw with like the one you can choose the apps, and then the app UI, which is individual apps that are sandboxed. So this is one of my favorite parts of all of this. It's not how the architecture works, but how data is delivered. So we are used to package managers like NPM, and NPM is great and everything, but have you seen the ESLint issue that happened like, I think 3 months ago or so? Like basically, these package managers can have a lot of malicious actors behind them. So you can have NPM trying to trick you into downloading some malicious software. You can have a manager from some package that just pushes a new version that is malicious, and then you do npx whatever, and you're basically like executing like malware in your computer. And we are doing that all day. We are like doing npm install and npx all day. And nothing happens, but then some days something happens, like the ESLint bug, and then we all lose a lot of money. So that's bad. So what we came up with is, instead of having a centralized package manager that is in a centralized server with everything that convenience, let's create a decentralized package manager. And so with a decentralized package manager living on Ethereum, you can do something like this. You can have a package maintainer which uploads some data to some decentralized peer-to-peer data hosting like IPFS or Swarm. And then this package maintainer can include a URL of where this data blob lives inside a smart contract, just like the one we saw earlier. And this smart contract is very simple. It just tracks versions of a new package. And then you can have different governance mechanisms for how these packages are updated. So you can say, I want to have a package registry in which I am the dictator, and I can just push new updates. Or I can have something more modular in which like I am the person, or like some committee of persons can push new versions, but the community has to review them and has to vote on whether they are malicious or not. And maybe they have some tokens, so like the maintainer has some tokens staked, and if the maintainer pushes some malicious code, then the community can say, hey, I want to slash your stake, and then you lose money. You lose like Ether on any token that you have in the smart contract because you were pushing a malicious code update. So this is very cool because, first of all, there is no centralized server at all. You just have references to where the data is stored on-chain, both for smart contracts, because you can also update the smart contracts with this system, which is one of the problems that the blockchain has. It's immutable by default. So with this, we can actually fix that. We can make smart contracts upgradable, so we can fix them and fix bugs as well, and release new updates and enhancements. But we can also release any data blob. So we can have a decentralized NPM, or we can have a decentralized Android app store, which is vetted by the community, and people can check what's going on. And there is no centralized server or company that needs to run this. you can just airdrop a bunch of tokens to your community and have them vote on the stuff of how these package managers will work. And I think this is how package managers are going to work in the next few years, because centralization doesn't help when there's a lot of at stake, such as with package managers or NPM. You do NPM install these days, and you have like a small library which can be called like is array buffer or whatever. Or I have seen terrible packages that are just like literally one line of code, and then they get a malicious actor in them, and your whole project is screwed. So we shouldn't do that. Another part of the architecture that I want to talk about is the apps and manifests. So basically, you have here, for all of the apps that we were seeing in the sidebar, for example, the finance app, they have a very simple manifesto. This is like a standard manifest for apps. And then they also have this other manifest, which says, OK, I'm a finance app. And as a finance app, I need to access a vault. And the vault is where the money is actually, it's a very simple smart contract in which the money is actually stored. So the finance app says, hey, as a dependency, I want to have the vault, and I need permission to transfer money from the vault. This is very similar to how permissions work in like Android or iOS. And using this very pluggable system, you can have different apps that request different permissions from the user and from other apps. So you can say, if you install the finance app in your organization, you need to have a vault where the funds are stored. And then, as you can also see here, the finance app can also define some roles, which is the permission, which is, as an app, what can I do for the other apps? And in this case, it can create new payments. So you can build really complex systems here, which have a lot of different functionality by doing like very simple modules. Just following like the Unix philosophy kind of thing. Just have a lot of very simple things, which is also great for security because the smart contracts shouldn't be complex because they can be hacked. And so I think that's great for the architecture. Then we have sandboxing. So what happens if an app is malicious and decides to try to steal some funds and decides to like tell the user, hey, sign a transaction with your Ethereum wallet because you will vote. But then what it does is it doesn't vote. It basically sends all the funds to like an attacker. So that cannot happen because then we will have to review every single app. We will have to kind of follow the Apple model and like review every single package, make sure that all the apps are not accessing any malicious API. So we don't want to do that because something that I forgot to mention is all of this code is open source. Because otherwise, if you have apps that are not open source, you cannot really trust what is running inside them in the smart contracts. But nevertheless, it's great to have a lot of sandboxing here. So basically, what we have is an iframe. And if I click vote, for example, this sends a message to the parent. And so the parent says, OK, this app wants to sign something. And instead of letting the app directly sign transactions, it shows another signer view at the top level of the app, at the parent level, which tells the user some information about what they are going to do. And so the user can make sure that they only can sign transactions if it comes from this parent level screen and not the other way around. And so when a transaction is signed, it goes to the Ethereum virtual machine. And then, for example, let's say this client was the one pushing a vote, and this client is the one pulling it, so like updating the UI. So basically, you can get the event from the blockchain, and then the parent context sends that to the web worker, and then the web worker reduces the state, and when the state changes, it sends that back to the app UI. The cool thing is all the web workers, as I will show here, all the web workers, all the background scripts are basically run at the parent context. So as you know, like they are sandboxed because you cannot access the DOM or do any of that. And so we actually fetch the web worker scripts from IPFS, and then we generate like a local URL for security. And so basically what we have here is we have a lot of, like, for example, 5 background scripts that are constantly fetching data. So when you open the app, it automatically loads. Because that's a huge problem for decentralized apps. They are great and censorable and unstoppable, but then like, you don't have any server that is caching for you. So you got to do these kind of things. And then finally, I want to show how to build a totally decentralized app using this system. I believe we have built the easiest way to create a decentralized app. You don't have to care about a lot of like smart contract heavy stuff. You don't have to care about upgradability. You don't have to care about package management. You can push new updates of your front end or smart contracts in a purely decentralized fashion. Something that I forgot to add is all the apps that we were seeing there, they actually use our package manager. So they are all fetched from IPFS. So if you go to like aragonpm.com, that is like a gateway to the decentralized world, to aragonpm.eth, which fetches the last hash in the package manager from the package you wanna get. So it's purely decentralized. There is no central server at all. The only central point of failure right now is our centralized gateway, which is aragonpm.com, which is like a .com domain, so that's a centralized point of failure. But then if you run your own IPFS node, it's purely decentralized. You can be in China, you can be whatever, it works. So this is how running an Aragon app works. It's very simple. You just do Aragon init, it creates your app, and then you do Aragon run. It does all the like blockchain stuff for you, so you don't have to worry about that. You just have to worry about creating a great user experience that is responsive and creating smart contracts that are easy, because you can leverage all the other apps. For example, you don't have to re-implement your own finance mechanisms or voting mechanisms. You can just put all the apps as a dependency, the voting and finance apps. Then you do Aragon run. It generates a local blockchain for testing for you. Inits IPFS, creates a decentralized organization, all the cool stuff. So if you want to try out how to create apps, I think that's a very cool way. Finally, I want to end up by talking a little bit about stuff that has been built. So for example, we all know that Microsoft bought GitHub, and we're probably not very happy about that. So Git was supposed to be decentralized, but then you have GitHub, which adds a lot of great features, and that is centralized. So with the stuff like Pando is a project that was built using the Aragon SDK. And Pando is a purely decentralized control version system built on Ethereum. So you have a smart contract, which tracks changes. And then you have the data itself in IPFS or Swarm on like a decentralized data provider. And you can add very granular permissions. So you can say, for example, these are the 4 maintainers, and these are the 4 people that can merge a pull request. But pull requests can only be merged in the code base if there is a voting and the community approves that. And you can do a lot of cool things here. So for example, open source sustainability. You can have a pool of funds into a decentralized organization that gets released over time as people make pull requests and they get merged. So that's very cool because there are projects like Python that don't have a clear leader anymore. And anyway, they shouldn't have clear leaders. These are community-run projects, and they should be run by the community. And it is the best way to run open source projects by a community. So I don't have a lot of time to get into a lot of details, but we've been working on these decentralized organizations for a lot of time, since November 2016. I've been into crypto since 2011. And decentralized organizations are truly the thing that can really solve a lot of the world problems that we are seeing here. From like, the like micro problems, like I'm a 15-year-old and I cannot create a company to contribute on open source or to get rewarded for working on open source, to like the macro problems, to like basically Donald Trump getting elected into the US because democracy doesn't work anymore. And I think decentralized organizations really unleash a lot of possibilities on how we organize. So we've been working on this stuff for like a year and a half, or the sandboxing, all these small pieces. So it's a truly decentralized app. When we release this, it's unstoppable. Like even if our whole team goes to Hawaii, or like we're in a plane and the plane crashes, it will still work. There wouldn't be a lot of commits yet, but a lot of like people committing. But at least it will work without us at all. So we've been also working on smart contract audits, because if you know about the Ethereum space, there was a huge hack a couple of years ago. $150 million got stolen because smart contracts are great, but as I said before, they were used to be immutable. And with immutability comes a lot of risk, because when you push smart contracts or code, as a programmer, it's very hard to make sure that your contract doesn't have any bugs. So we've been working on this for a long time. We have underwent like a lot of like security audits to make sure everything is great. And after a lot of work and a year and a half, everything that I'm using here, which before today was just testing, you could just test them. And by the way, there are more than 15K organizations created this last year with Aragon. That's more than the number of businesses in Malta, Luxembourg, and I think like Finland together for the same period of time. So this is like, this creating more businesses than like countries, which is great. But they were all test. They were all running on a test network, so we don't lose any funds, because we wanted to make sure everything was right. And after a lot of work, today, everything is finally right. And we are releasing Aragon 0.6 Alba, which you can try now at mainnet.aragon.org.
Thank you very much, Lewis.
And I still have a couple of things, just very quick. If that sounds interesting, we are organizing a conference in Berlin called Aragon, Aragon.1. Check it out. It's in January. And finally, if you want to hack.aragon.org. You can experiment with governance at this bit of software, finally. And one last thing, come to drink beer with us. So 7:30, we are going to be drinking beers, and the whole dev team is going to be with us celebrating this launch. So that's it. Thanks, everyone.
Fantastic. You ready for a few questions?
Sounds great.
Yeah, good. Let's go for the first one. What is the use case for ANT tokens in this system?
That's a great question. So ANT is a token that we released, and basically ANT fixes one of the problems that there are with decentralized organizations. So as I said before, all of these, you can use it without any token, because we believe this is core infrastructure for the decentralized world. This should be free to use. But then what's the problem with the smart contracts? They are great because they are computer code, so they are efficient. You can, for example, have a payroll app, and we are going to have a payroll app for ourselves to pay our own salary on-chain without doing anything. It just pays you. But then you have more complex stuff. Like, for example, imagine you hire someone, and you want to give them a laptop, but they sue you because the laptop was compromised or something. These things the blockchain doesn't know about. So what we are creating is a purely decentralized jurisdiction called the Aragon network. Using a country, it will have a court in which you'll be able to settle disputes in a purely decentralized fashion. No centralized court at all, no centralized legal system. Everything is going to be decentralized and community run. So that's the use case for ANT, governance over that network.
Great. Next question from Anonymous. Since you can't delete entries in blockchain, how can you respect the right to be forgotten in Europe?
That is an amazing question. And I don't really have an answer for that. It's very tricky. The good thing about the blockchain is you can be pseudonymous. So what I encourage everyone to do is don't use your real name. Let's come back to like the 90s, where Facebook wasn't a thing, and people were just valued for their content and not for their nickname or Twitter followers. So I just hope we come back to that.
Mm-hmm. All right. Don't you think owners of packages can still inject malicious code?
Well, they can, but we reduce what they can do a lot. They cannot sign transactions. And if it's like a generic package deployed to the Aragon package manager, at least you can have a community veto, so they can check the code and be like, no, we're not pushing this out. So nothing is perfect, but this really, really increases security for like all apps that you can run, basically.
Mm-hmm. All right, what are you doing better than other products like ADA? There are so many ERC20 tokens out there without a real product. Do you have a working product that is used?
Well, I don't want to talk about the token so much because this was about the architecture, but basically that token, there is a blockchain. We are not a blockchain. We run on Ethereum. So the token is for the governance of the Aragon network. So I don't think it's comparable to like those tokens. And I mean, each token has its own functionality. A lot of them are scams. And ours is just a governance way for people to control the Aragon network, because we are really into this thing of like being community governed. We think these goods should be community goods and run by the community.
Okay. Any comparison to DAT protocol, Beaker browser?
Yeah, so the DAT protocol is something more similar to like IPFS, so it's a decentralized storage system. We use IPFS, and we could also use DAT, for example. I think it's great for storage. So you could build the Aragon package manager on top of DAT. Actually, we support any data reference. So if you put like a DAT reference and you implement some code inside our library to fetch files from not only IPFS but also DAT, it will work. So yeah, it's fine.
Mm-hmm. Next one, Lewis. Who pays for the computation power?
OK, that's, well, right now is the users. So if you want to create a decentralized organization today, you have to pay fees to the Ethereum network, and that's around $10. Which is still like probably less than when you get for like incorporating a company. Like for example, in Switzerland, it's like 100K or so. So I think 10K is a fine price to create businesses.
Mm-hmm. Probably time for one last question. How will you prevent 51% attack?
Inside the blockchain, well, that's something that the blockchain has to do, like, we are not a blockchain, so we are relying on the blockchain to work. The thing about 51% attacks is you can do two things. One, have economic incentives, so that's very expensive to do, like hundreds of millions or even billions of dollars. And second, you can hard fork. So you can be like, I don't like this entity here that is trying to attack me. I will create another fork without this entity in the system. And you can do that.
Fantastic. All right, let's give Lewis a hand. Thank you very much.